Right. Welcome everyone to our first lecture in the Introduction to Programming with R course. My name is Marcelo Ponce. I hope that you guys can see me. Um, I'm going to take a few minutes to just chat a little bit to give time to everyone to join either the meeting or the chat room in the course website. Um, we had a variety of different terminologies going on at the same time. I think I mentioned this in the previous emails. Um, and so we had the Zoom meeting, which you probably guys are seeing. We have the YouTube channel. Yeah, thank you for posting that, Dorna. The YouTube channel is also embedded in the chat room from the education website. And then, of course, after class, we will have the recording of the lecture. Um, Again, if you experience any type of technical difficulties like sound not playing nicely or video not playing nicely, please try to let me know as soon as possible so I can try to see what can I do in order to fix that. Right, as I say, I'm going to just try to give some few minutes for everyone to join the class. I will like to start usually sharp, but if you have been at U of T, you know there is this tradition of starting 10 minutes after the hour. We can try to keep that tradition going. So it's up to you guys if you want to start sharp at the hour or 10 minutes after. I don't basically care. But just let me know in the comments what would you prefer. The other thing is I'm planning to use Zoom for the office hours. So far is the only way we have this kind of two-way communication thing going on. So perfect. It looks like everyone. So at least some of you are preferring to sharp. That's great. That's great. That's really fine with me. Yeah, for the office hours, what I'm going to ask you, and I'm going to go much more in detail in few minutes, is to complete a survey that is open after the end of the class today until midnight today. When will you prefer to hold the office hours? Which day and time? And the options I have in mind are so it could be just one day or split in 2 days. So the days I have in mind is Mondays and Wednesdays, and I don't exactly recall the time slots I wrote there, but I think it's the same time at the as the class. But again, that's we can take a look at that as well. Okay. Let me see. So we are 104. So I think I'm going to start with the material. I think we have a few more folks joining us. Welcome, Francis. And as I say, if you have questions, please let me know. Okay, I will try to monitor things so things may go a little bit slowly, at least the first time. Okay, so let's go to the slides. So I hope that you guys can see my slides, otherwise please let me know. By the way, because we are recording and I'm trying to keep an eye on everything, you may see the chat in the recordings. So just to let you aware is we cannot have privacy, complete privacy and this kind of communication. So your names and your comments may show up in the recordings. Okay, we try to keep privacy as much as possible, but you probably should be aware of that. Okay, so again, welcome everyone. My name is Marcelo Ponce. I'm going to be the instructor for this course. I work at Scinet. which is, maybe some of you know or don't, is the Supercomputer Center at the University of Toronto. So we host actually the largest and fastest supercomputer in the country, available for researchers and academics to run different kind of research based on computations. So little bit about this class. So this class aims to be an introductory course to programming, and the language that we are going to be using is R. But my hope is that the techniques that you're going to learn can be transferred to any other programming language. We are going to be meeting for the next 6 weeks, twice per week, Tuesdays and Thursdays, starting today, of course, from 1 p.m. to 2 p.m. Because the current situation we are living, this class will be completely online. And some elements I have to tell you we have been using since long time ago in our courses, like the recording, and you will see all the technology and tools available in the course website have been there since really long time. So some things are not really new for us. Others we have been playing a little bit in the last weeks and months. For approving the course, you will have to submit 6 assignments. At least that's the original plan. We will see how this goes, depending on the questions that you may have and so on. But the idea is to have 1 assignment per week. And then the first assignment is going to be presented this Thursday after the class. And you will have 1 week to work in the assignment, and we can go much more in detail to that. But the final grade will be the average of these 6 assignments, and you have to submit all of them in order to approve the course. I usually recommend that you submit the assignment in time. So the strategy which that we have is I present the assignment on Thursday. You have 1 week to submit the assignment, and that's the deadline next Thursday. But if for whatever reason you cannot submit the assignment on time, we give you 1 more week, but at half-point penalty per day late. So after that first week, you will start losing half-point out of 10. So I really encourage you to try to keep up with the assignments. First of all, because it will help you assimilate and put in practice the concepts we are going to be discussing in class, but also is a way to don't lose marks. The submission of the assignment is through the class website, and we're going to go through those details on Thursday, so you don't have too much information to digest today. I mentioned this at the very beginning. Office hours will be online as well. My idea is Mondays or Wednesdays, and I have a survey. It shows up as a test in the course website, and it will be open after the class end today until midnight today. So you can select. I think there are six options there. You can select the one that fits better with your schedule. If you have any questions that you want to ask, either about the class material that we cover, either about the topics that we will cover, anything related, please email me. I'm going to show you other tools that you can use, but if you want to have a direct communication, just email me at courses@signet.utoronto.ca. Just to let you know, one of the things that we usually see in this type of courses is that after a while, after even the course finished, we have students coming back to us asking questions about how to analyze data, how to program things. And in some cases, we have really interesting discussions and really interesting collaborations where we are able to actually even write papers or do some research together. So by all means, I know this is a very strange situation, the one that we are living nowadays, but I really encourage you to email us any kind of questions that you may have. You receive this information from my previous email. That's the course website. All what is related to the course will be there. That's a short link there, signet.courses/526. you already know this because you are either in the Zoom meeting or in the chat in the website. We will have these two ways of streaming the lectures. The lectures, as I mentioned at the beginning, will be recorded and posted on the course website. So again, be aware of that. Slides of the lectures will be posted in the course website at least the day before the lecture, so you have the chance to review the material, especially in this online format. I would encourage you that you take a quick peek at the material. If you notice something that can be of interest for you, or something that you think it may not be clear enough, we are going to go through all the material, but you can just have a quick overview of it. I think I mentioned this. Office hours will be online as well, most likely using Zoom. Now, be aware that the office hours will not be recorded. The idea there is that you guys have questions, you are working the assignments, or you have questions about the material we cover in the lectures, and I will expect you to be the main actors there, and I will just try to address your questions. I have my email again here, courses@signedutoronto.ca. Of course, you receive my emails from my personal address. You can either write to any of those. I prefer the courses@signet.utoronto because it's a way to aggregate all the information for me about the course. And in some cases, I have colleagues that can also help answering the questions that you may have. Also, please let me know if I'm going too fast. I want to mention this as well because this is something quite interesting. All of you are taking this course as part of your graduate degree at the Department of Biochemistry. But in addition to getting the credits for this course, you will also get what we call Signet credits. And what we have at Signet is a certificate program. So basically, we will issue a certificate after you obtain 36 Signet credits. And we have three types of certificates. One is in data science, one is in scientific computing, and another one on high performance computing. So depending on which courses you take, you may get credits on these different parts. For instance, I believe this course has credits going 9 credits to the data science certificate and 9 credits going to the scientific computing certificate. I had someone saying, Laura, claiming that she can see the slides changing. Is this happening to everyone? Oh, okay. Let me see. Okay, I think that happens when, so let me see if I can fix that. Okay, you should be able to see this. Yeah, so the thing with YouTube, so these are, as I mentioned at the beginning, and I apologize for that, is we had a couple of different technologies going on. So Zoom is a program that allows you to do this kind of meeting and conferencing. And at the same time, I had another streaming service going to the YouTube channel. But I think the problem was because I was bringing different screens to the front. Now I think you should be able to see my slides changing. So I was talking about the Signet certificates. Okay, I think I fixed that now. Please let me know otherwise. So as I was saying, the class will also give you, when you complete the class, it will give you actually 18 credits, 9 towards the data science certificate and 9 towards the scientific computing certificate. What else? If you want to know more about that, please visit our courses website. We have we have a great variety and a long list of courses because the current situation, this has been, let's say, put in pause for the moment. But hopefully when things go back to normal, we will come back with way more courses so you can complete your certificates credit. if you are interested in that, by the way. And I had to tell you, again, our previous students, even people that have graduated and are postdoc, they had told us that these are really great for finding jobs either in academia, doing research, or even in the industry. So it's something to keep in mind, and this comes for free as a parallel thing to the graduate course that you are taking right now. So what are the classes expectations? Okay, so the prerequisites are basically known, I would say. We have minimal to no programming experience. So the goal here is that we're going to start really slowly, and we will try to build up upon things. Again, if you have some experience, it may be too slow for you at the beginning. So I please ask you to be patient a little bit. I think we are going to cover very interesting things, but the first week probably is going to be a little bit boring if you have some experience. If you don't have any experience at all, please let me know how do you feel about the pace that we are covering things. Okay, if we need to spend more time here or there, that's just fine. Of course, that usually is easier when we do it in person, but we will try our best to keep up with things doing it virtually. What programs, what software are you going to need? Okay, this is really important. You are going to need what we call a text editor or a code editor, and I have some suggestions here. Atom and Sublime are really good ones. There may be other ones. The one I use personally is something very, very high level or low level, is BI, but these two are just fine. And if you install R, which is the other main element, of course, we're going to need, R brings also some sort of code editor, so that will be just fine. I mentioned this, the grading scheme is the final grade will be based on your homework assignment, and it will be the average of the 6 assignments which you have to submit the 6 assignments. Attendance is not mandatory, of course. We're not taking attendance right now, but I will say it's strongly encouraged. It can be during the lectures itself, or it can be by watching the recordings later on, but I will encourage to do that. Okay, so if you haven't visited the class website, probably all of you have done this by now. This is more or less how it looks like. So on the left you have the main website, on the right you have our own course website. By now you should have received your signed accounts. I believe that if you haven't, you probably are not going to be there because a lot of information goes through there. But it's crucial that you can log into the course website. So one thing that you're going to verify today after class is by completing this test, this survey. I ask you to select which is the best time for you for the office hours. Okay, so I hope that everyone can do it, and if anyone find any trouble, please let me know. Okay, this is something I have to mention, is part of the formality of the course about the student code of conduct. And this is more important even nowadays in this particular format of the course that is going to be online. And what it basically says, what it basically boils down to say is don't copy code from each other. All your assignments are going to be submission of scripts and code that you should write your own. So please don't copy. You are welcome to discuss even in maybe online with your colleagues. Of course, you will be able to do Googling and searches online. I promise you all the material that you need to solve the assignments, to complete the assignments, will be within the lectures. So at the end of the day, if you are going to spend hours Googling for a solution online, you're going to be wasting your time. First of all, because it will take a good amount of time to find the right solution, because we try to be really creative with the assignments, so you won't be able to find that easily. And you will be basically wasting the opportunity to put in practice what you are learning. And of course, please don't copy the code from each other. That's yeah. As I say, it's more a formality than anything else, but please don't do that. Okay. What we are going to cover in the class, and I'm almost taking 1/3 of the class, I'm going to try to finish this introduction very quickly, is we're going to, of course, discuss the R language. We are going to discuss data structures, what type of data you can store in R. But we're going to discuss also some basic programming strategies and concepts like modular programming and modularity. We have, it's a must if you are learning R to discuss some statistics, because R is a language aimed for statistics. Then we are going to come back to some basics of computing like file input and output. We're going to discuss some visualization, and then even when this is a very short course, we may have some freedom to pick some different topics that you may want to cover. And among the topics are, of course, we can do some more statistics, for instance, machine learning. We can do some high performance computing with R, or if you have any particular topic that you would like to cover or to see cover, please let me know. We as I said, we may have some freedom in order to try to accommodate the needs and the interests of you guys. Okay, so for starting the actual class, let me check. I don't think I have any questions in any of the chats. For starting the actual class, what we're going to discuss today is an introduction to R, how to start R, the primitive data types that R offers, and container types. And so these are the very basic blocks for starting to know how to actually instruct the computer to do what we need to do, because that's all what it is about programming. Okay. I think we are fine. Again, if you have any questions, please. I think you have a feature in Zoom. Raise your hand if you want to speak up, or just put the questions in the chat. So let me start with the very basic. What is a computer program? Okay, so a computer program is nothing else than a set of very precise instructions that tell the computer what to do. Okay, so it's like a recipe for doing something in the kitchen. You need to follow these precise instructions, and that is what the computer is going to do with our computer program. What that implies? Well, generally speaking, and especially in scientific computing, I would say, you basically define some variables, which will be where you store the data, and you perform some operations on this data, and do some calculations, and then you share the result with the user. So I'm using here the word variable, and when I mention variable in programming, what I want you to think about is a place in the memory of the computer when you can store different type of data, of values. The next word I mentioned here is functions, and functions are like procedures. I can define my own functions, and then apply what are the elements of this function to the data that I have stored in the memory of the computer. And the nice thing of this is that you can reuse over and over these functions with different values, with different variables that you pass into the functions. There are a lot of programming languages with different strengths and different weaknesses. The one that we will be using for this class is R. And there are some reasons why to do that. So let me tell you a little bit about the story of R. So it has been around for a while. It started by being what was called at that time the S language, and then it was renamed to R. R is especially designed for exploring and analyzing data in particular, and most of the statistical things that you may want to do with the data are already part of the R core package or developed in libraries. So it's very well suited for any kind of statistical analysis of kind of problem. The home page for R is this URL right here. And then what you have is a great variety of packages, additional packages, libraries are called, that you can find in what is called CRAN, the Comprehensive R Archive Network, or Bioconductor, which is the main archive for bioinformatics. A new version of R is released every year. We are actually using version 3.6.3, so that's the currently one right now. I got an interesting question before the beginning of the class by one of you, and I think it's very it's a really good thing to mention as well. You don't need to be in the last version. All the code and things I'm going to show you should work with previous versions, and I usually try to keep it that way on purpose, because being at the bleeding edge of the latest versions also implying that you are subject to new bugs that sometimes is hard to debug, to find new problems that it's hard to find when you are in the bleeding edge. Actually, the pre-release version 4.0 is also available to download from now. I strongly encourage, don't do that unless you really want to practice and try the new things that they are planning to develop for R. So version 3.6.3 or any version up to 3.5 something should be okay. All right. So a little bit more about R. R is what we call a scripting language. So if you are familiar with the Linux shell or with Python, it's the same idea. So it means that when you open R, you will have a prompt, meaning that the computer will be waiting for you to introduce commands, and R will interpret these commands one at a time after you hit enter. R can be used interactively with or without an IDE, and I take the opportunity to mention here RStudio. Many of you may be using or are familiar with RStudio. I won't be using RStudio, but you are welcome to do that. I teach another course in the fall where we actually ask students to don't use RStudio, because one of the main disadvantages of RStudio is that you lose something called command line arguments. And that is the possibility of communicating into your R programs information coming from the outside world through the command line. We are not going to cover this in this course because of the time we have. We have just 6 weeks, but that is a weak point with RStudio. Having said that, RStudio offers an integrated development environment. That's what IDE stands for. And it's very nice if you are starting for the first time programming. So in this case, if you would like to use RStudio, that's just fine with me. R can be also used non-interactively, running scripts. So we're going to see a little bit of this in lecture 4, I believe. R has a large repository of community packages. Those are the ones coming from either CRAN or Bioconductor. And nowadays you can also install packages available in GitHub. As I mentioned, this R is all about data analysis, so it's not a really general purpose language, but several important features like numerics visualization are part of the language itself. And R is also designed with the idea of doing a lot of interactive data exploration or manipulation. So surprising things just work interactively. So we're going to see examples of this probably next class. Now, one thing that to bear in mind, and I have mentioned this term 2 times now, bug. So bug, it refers to when you have a flaw, a problem in your program that of course you are not aware of. So finding those problems within your code can be a little bit tricky in an environment like this. But don't worry, we're going to discuss some techniques in how to mitigate this. It's almost impossible to write a code without bugs. It's by definition your code always has bugs. So all you can do is try to follow best practices so that you can mitigate or have good tools to try to investigate and find these bugs. So starting out. So if you are you can follow along this part of the class, in particular if you have already installed R. If not, you can come back to the slides and follow later on. But if you install R, basically you can just, independently of the operating system, you can basically find the R icon, double click on it, and a new window will pop up. What I usually do, I like to do actually, is open a terminal. In particular, that's how it's called in Mac OS, or if you are in Linux, or if you are in Windows. I believe nowadays they have a Ubuntu subsystem that allow you to do that. But if not, if you want to try that, you can email me and I can send you some information on how to do that. It doesn't matter how you do it. The important thing is that you can start out just by double clicking on the icon. Okay? And if you do that, let me see if I can switch my share screen here. So I'm going to try to share So you should be able to see a terminal now. And a little bit. I hope the font size is good enough. So I'm in macOS in this case, and I'm going to just type R. And again, this may be different depending on the operating system that you are using. If you are using Windows, this won't work. If you are using Linux, you probably just open a terminal, whatever terminal you use, and just type R. And I'm going to type R and hit enter. And this is what it shows up. So this is the welcome screen from R. It says R version 353. That's the one I'm using in this case. Some information, and now you see this greater than symbol with a blinking cursor. So that is what we call the prompt. Okay. So I just wanted to show you how to open R in the terminal. If not, if you double click on the R icon, something similar should have popped up in your computer right now. It can be that it looks a little bit different, but more or less, with the exception of the version and some of the text here, it should look more or less the same. Okay. So let me go back to my slides. Okay. So we talk about this greater than symbol. That's the prompt, means R is waiting for you to input instructions. So let's take a look. So what I have here on the right are examples. So what I'm saying here is I'm typing the character A, and then this kind of arrow thing pointing to the left is nothing else than the smaller than symbol followed by the dash or the minus sign, and it says A smaller than dash 1. What it means is I'm putting in a variable called A the value of 1. So this left arrow, if you wish, is the what we call the assignator operator. So we are telling R, okay, from now on, when I say A, you need to give me the value that is stored in A, and in this case is the number 1. Okay, so I can type A, this thing, 1, and then you will see A, and if you type A, you will say A has the value of 1. Similarly, I can use this other expression where I say A, assign to A the value of A plus 1. So what happened here is the right-hand side is evaluated first. So R looks first at this part where it says A plus 1. Because A has the value of 1, as we assigned it before, now A plus 1 is 2, and that is assigned again into the variable A. So if I say A and hit enter, R will respond with 2. Okay. Similarly, I can say A divided by 2 plus 3, and now if I ask this, A will say, if I ask what is the value of A, R will say A is 4, because A was 2 before, divided by 2, I get 1, plus 3, that's my 4. Okay, so let me see, I think I have a question. Excellent question. Can we use equal instead of the left arrow? The answer is yes. My recommendation, though, is no, for 2 reasons. Reason number 1, if you go into the R community and the developers of R, is a recommendation they tell you, don't use equal instead of the left operator. The second reason is, or there are 2 more reasons if you wish. The second reason is you may run into some bugs, into some errors in your code when you're asking for equality. So if I want to know if variable A is equal to 1, and let me see if I can pull up my terminal again. Okay, so now you should be seeing my terminal. Okay, so I was saying A, I put A equal 1. If I type A enter, then A is 1. Now if I want to ask the question, and I'm going a little bit ahead, but I'm just saying why it's a good idea to use the left arrow instead of the equal sign. If I want to ask, is A equal to 4? Now I have to write 2 equal signs. Okay, and if I ask A is equal to 4, then R says is false, and we're going to see this in a second. So basically, you may sometimes confuse the one equal sign with two equal signs, which is the way to ask for equality. Okay. The third reason is, and we're going to see this, the equal sign operator, in addition to assigning something, is restricted to when you define default arguments for your functions. And we're going to see this next class. So, but these are the two or three reasons why I would recommend not to use the equal operator. Okay. Yes, so the another question in the chat is, can I do something like a plus 1 assigned to a? Yes, but I find it a little bit confusing, because after you get used to programming, you see that the usual flow is take whatever is on the right of the operator and store it on the left. I have seen code doing that thing, like doing a plus 1 assigned to a. It does work. I wouldn't recommend doing that, just because the way I have seen most of the code being written. So again, it may be a personal taste. Okay, great question. What is this bracket 1 thing? What it means is that's the first value stored in A. Okay, keep that question in mind. We're going to come back to this probably in few slides, okay? But I'm going to mention this again very quickly, okay? But that is some additional information R is returning to you in how the data is laid down inside the variable, inside the memory, okay? So let me go back to my slides. So let me see, I think okay, we were here, we talked about this. Okay, so let's say we have a value assigned to the variable a. Now I can use, so this type of is a function that R provides, okay? And it tells you what type of data is stored in that particular variable. So the name of the variable here is a, and if I write type of and parentheses, and then I put the variable inside those parentheses, what it will return is what is the type of that variable, okay? And this, by the way, is the usual way how we call functions. So this is a function called type of, and whatever I want the function to use as the argument, as the information to perform the operation that the function does on, goes inside those parentheses. So in this case, type of variable a is double, which means it's just a type of number. So this is a number, and this is good because now I can perform, as we were seeing before, I can perform mathematical operations with it. Here, for instance, what I'm doing is taking the type of result from the previous line and assigning it to the variable b. And now if I type b, it says it's double. But it says double between quotation marks, and this is an important difference. Now, there is another function that you can use. These are called diagnostic functions, and as is whatever goes inside the parentheses a number, so is numeric parenthesis a, and it says true. But if I ask is numeric of b, it will say false, because b now is a string. It means that it's a collection of characters. It's basically text. I cannot perform the mathematical operations with text, with strings. Okay? So, I think whatever is written here is more or less what I just mentioned. Okay, so there are a couple of interesting details here. When I call a function, like here, if this is not assigned to a variable, what R does is just print in the screen the result, and that is where this bracket 1 comes from, actually. Similarly, when you assign to a variable and then you type the variable, it's going to basically give you the same output, so the bracket 1 will be there. In some cases, what you will notice is that the functions, for instance, the functions that we are using here, they return something. But in some cases, they won't need to return something. And that's something that we are going to see much more in detail in next class. Okay? Any questions so far? I keep in mind this bracket one thing, and I promise I will come back to that in a second. Okay. Now let me just do a quick parenthesis here about the type of programming, and this is coming back to why R is interactive programming language. So basically what had happened before is whenever we had this prompt and we enter commands, R reads that instruction and executes things, and that's the output that you see when R interprets whatever that command, that function is, and the result is the output of interpreting that. But R can also be run by writing scripts, and what that means is we are going to put all these commands together in a text file, which then we can fit into R. R will read line by line and execute those lines as if you were typing them in the terminal. And this I can express how useful it is, because imagine that you have data coming from the lab, from an experiment, from a database, whatever, and you have to perform a statistical analysis on the data many times. You won't be, or you don't want to be writing every time the same commands or slightly variations on that, when you can have all those commands in a tiny script, in a tiny file, and say, okay, run all these commands on my data. It will save you a lot of time. It will avoid having typos when you type things. That's one of the annoying things with programming. One has to type things, and that usually implies having typos and bugs. So it will save a lot of time, and the most important thing probably nowadays, it will allow you for reproducibility of results. So having this script is one of the main elements of this course, and it's one of the main things that we are going to be evaluating throughout the course. Okay, so that's one of the things I wanted to mention. Now, let's change the type of variable that we were discussing. We were discussing before numbers or numeric type of variables. Let's assign now to the variable e the word hello, okay? And this is written with double quotation marks. Then I'm going to assign to the variable she the word war, and these two are strings. It's a collection of characters, text in other words, okay? So let me see. Yeah, okay, thanks Francis for that. So what I'm going to do now, I told you I cannot perform arithmetic operations here. So if you do e plus she, R will tell you those are not the type of things I can add together. But what I can do is I can combine these two things. And this paste command is very useful. So paste is another function. So and you may see by now I'm sometimes using the word function or command as the same thing, and in some way it is function and command in R. So paste function or a command will take these variables e and she, which are separated by a comma, and the result of this is going to be stored in a new variable called myString. So now if I use the function or command in our print myString, it will say hello world, which is the combination of these two strings. Alternatively to print, which as you can see has the bracket 1, you can also use cat. Cat is another function in R that what it does is it takes several strings and combines them together in one output. So in this case, cat is taking the variable e, which has hello, the variable she, which has war, and then this funny thing, single quotation /n, single quotation. That's another string, but it's a special string because it has this symbol which represents a new line. So it means it's like hitting enter at the end. Otherwise your prompt, if you don't include this, your prompt will be just next to the word hello. To the word hello world. Okay. Now, if we go back to our previous type of function and we do it with e, now it says that the type of variable e is a character and it's not more a number. And as I was telling you, if you do e plus she, R says, no, I cannot do that operation because these are non-numeric variables. That's what the message mentioned there. Okay, I think I have another comment in the chat. Let me see. Difference between hello, double quotation, word. No different whatsoever, but you have to be consistent. So, and the reason why both work is because sometimes you may want to have text that has quotation marks inside. So if you want to have a text that has a quotation mark, a double quotation mark inside, then you will say, let me show you an example. You will say you start on single quotation marks, and then you will say something like double quotation marks, whatever you want to say. For instance, I'm going to say message is my variable, and here I'm going to start with single quotation marks and say welcome to, and I'm going to open BCH2024, single quotation marks and close with double quotation marks and close with single quotation marks. So now if I do if I do message, now it says welcome to, and it has these funny slashes. It's just the way that is showing you, but you can do something like cat message, and the slashes are gone, and you can see what I was saying before. If I don't write the -n at the end, my prompt is just next to the text that the cat function brought. So I can do cat message -n, and now boom, the new line character is introduced by adding -n here. So that is very helpful when displaying information in the screen. Now another thing that I also had, I think in the slides at some point, is that if you want to reuse commands that you have written in the terminal, in the R terminal, you can use the up and down arrow. So I'm pressing my up arrow now, and you can see I'm going through the history of commands I just brought in this session. Okay, so that is very useful because it avoids you to have to write things again if you are trying things especially. Okay, so let's go back to the slides. So we were doing the E+G thing, okay? That was a really good question. Thank you for that. Okay, so as we say, there are at least two types of variables that we have discussed so far: numbers and strings or text. And sometimes we shouldn't get confused with them. So A, we can reassign the value of 1 to A. B, we can assign the character, the letter, the text A, and if I type B, now it should say A. Now, if I assign, and this can be a little bit tricky, if I assign A to D, D now should have the value of A, because it's not the letter A stored in the variable B, but it's the value of A stored in the variable A. Okay, that makes sense? Just to let you know about that. By the way, the choice of variable names I had done for this example is really, really bad. And the reason is, well, it's the introduction, so I don't want to go into complicated variable names, but that is one of the things that we are going to cover: how to write code in an elegant and proper manner. So when you read the code, by just looking at the variable names, you can get an idea of what that variable represents. A, B, and D so far here means nothing, and you may be noticing I skipped the letter C on purpose, and there is a real good reason that we are going to come back to that, why I'm skipping that. Okay. Third type of variable that we're going to discuss today is what we call Booleans or logical variables. And you have seen this one already when I asked the question, is A equal, by using the double equal sign, to a number, to a particular value? And R says true or false depending the question I was asking, or is numeric, or is character, that's another function. So I can assign to the variable F again. Very poor choice of variable names so far, don't worry about that this lecture at least, the value of false. And notice that false has to be written all in capital letters. So this is another important thing with R. R is what we call case sensitive. It means that capital F and lowercase f are not the same thing for R. And in particular, the word false, which represents a particular code, a particular value, has to be all caps, okay, all capital letters. So if I assign false to F and then I type F, R will say it's false. Now, if I want the opposite, and this only works with Boolean operators or Boolean logic, if you wish, I can put exclamation sign in front of F, and now false converts into true. Okay. If I use type of f, I will say, okay, this is not a number, this is not a character, this is a logical Boolean value. Okay. And of course, there is logical function, which tells you if a variable is a Boolean or logical, and in this case, it's true. Now, something funny that happens with Booleans in R, and sometimes can be useful, is that you can add Booleans. So I can add true plus true, and that gives me 2. And if I have another true here, it will be 3. The reason is that R internally represents a false with a 0 and a true with a 1. So you can use this for actually asking questions. If we're going to see much more details on that, but just keep this in the back of your mind. 3 types of variables of R: numeric, strings, Booleans, and Booleans internally represented in R as 1s or 0s. Okay? The exclamation sign here represents the not operator, which basically reverses or converts a true into a false or vice versa. Okay, so kind of a summary so far. We have seen numeric types, which include numbers basically, don't worry about the names, logicals, which are Booleans, meaning true or falses, and character strings that represents text. This is the assign operator. As we mentioned, you realize that the equal operator works. I will advise not using that, but it works. Logical literals are shouty, as I like to say, so all capitals, or you can short them by just T or F, but again, all in capital letters. Variables can have periods in their names, and that is useful, especially when being explicit about what a variable means. Okay, this is super important, and we are going to actually emphasize this a lot. Your scripts and your functions should have comments, and the comments start with the hashtag symbol or the pound number symbol. What it means is when you type that and you type whatever, R disregards that completely. But they are so important because those are the hints, those are the explanations that the programmer leaves for another human being looking at your code. Okay, so those are going to be crucial in your assignments. You're going to be also docket marked by not having them or not having clear comments. So we are going to spend some time talking about them in next lecture. Okay, I mentioned this. R is what we call case sensitive. So capital A is not the same as lowercase a. Okay, sometimes sources of bugs here as well. One more thing on the technical side, R does what we call dynamic typing. What it means is, okay, I started by assigning to the variable A the number 1, and if I ask what is A, then A is 1. But right away I can say, okay, no, A actually will take the value of the string pants, and R will not doubt about it. It will just overwrite whatever was in the memory in the variable A, and it will write pants. And I can do true, I can convert into a Boolean. So that's what it means with dynamic typing. Now, when you do this in another type of language, this won't work. Like in particular, if you do something in those type of languages that requires a compiler, not an interpreter, they will just crash your code while the compilation happens. So I will strongly advise against doing this. I just mentioned this because you may see codes written in this way. There could be some reasons for doing that, especially if you are dealing with very large data structures. In order to save memory, we may talk about this if you decide to do the HPC R class. But from the programming perspective, it's a really bad choice, I would say, because it can confuse the program. It can confuse the human being reading the programs. It is true that we write programs for the computer to perform those operations, but probably the most important part is the human being reading the program to understand what the program means. Okay, because that is the connection that has to be between the human being and the computer for the program to work properly. So again, this is possible. Please don't do it. Okay, it's not a really good practice. Now we are going to start very quickly what we call the composite or container data types in R, and these are variables that can contain different types of variables. So we saw the numeric types before, we saw the text types before, we saw the Boolean. What about if I want to create a variable that has different types? Well, guess what? There is what we call the list, which is a container type that allow you to store that. So here what I'm defining is a variable called L. I'm assigning operator, the function is called list, and then I'm going to put there my previous variables, A, B, E, F, G, and actually the value pi. So the value pi, 314, blah, 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 is predefined in R. So by doing that, I define in a variable L. I can use another diagnostic function from R called str for the structure that will tell me what is the structure of this variable L, and what it's telling me is a list of 6 elements. The first one is a logic, a Boolean. Second one is a character. So remember, A was in the last time was assigned the value true. Okay, that's why it's a Boolean. The character comes from the variable B, which was A. E was hello before. F was false. She was war. And then pi is a constant predefined in R with the value of 314, blah, blah, blah. Similarly, I can use this isList diagnostic function to ask, is this variable a list? And R will return true because it is indeed a list. Okay? Again, super important, will be part of your first assignment, I think. Now, this comes back to the question of the bracket 1. Remember some time ago you asked me about bracket 1 in the output? Well, R tries to tell you in the outputs if it is returning a simple or a native or a basic data type or a container or composite data type. And the way it does it is by this bracket notation. So when you use double bracket, you are accessing one element within the list. So if I do L bracket bracket 6 bracket bracket, it says bracket 1 314. That's the 6th element in the list, which is the value of pi. Now, I can do what is called slicing. We're going to come back to this. It's a very powerful technique. I can do from the list, give me the elements 1 to 3. So 1 column 3 represents elements 1, 2, and 3. And what it's telling me is, okay, first element in the first entry is a true. First element in the second entry of the list is the value of A. Third element of the list is the value hello. So you can see that when our list, you have double bracket. When you have a single object or the type of object is one of these native types, there is just one single bracket. So in the previous output, what R was telling you is that the output was a single variable, one of these native type, basic type of variables, and not a list per se. Okay, so I hope that I could clarify that question from before. Otherwise, let me know. Okay. Now there is so that was the very straightforward way of defining list. There is another way you can define list, what is called named list, and again this is super useful, and I think it's going to be again part of your first assignment. So in this case I'm calling this named.list, so that is where I can use periods in my variable names. So it's a variable name. I'm going to use the list function again, but now I'm going to say, instead of the first element being just a variable, I would say value equal 5. I could say value equal the name of the variable, word equal text, and number equal another name. If I ask for the structure of this object, now R says it's a list of 3 elements. The first one is called value and it has the value 5. The second one is called word and is a string and has the value text. And the third one is a number, it's numeric, and has the value 7.3. More importantly, I can use this $sign notation to actually get the actual value of the first element. So I can say named.list $sign value, and I get the actual value of that spot in the list. I can alternately use bracket bracket notation, as we saw before, with the name as a string. So the quotation marks means I'm specifying the name of the spot in the list as a string. So if I say named.list, my variable, bracket bracket quotation mark number, I will go and grab this value from here. Okay. Finally, I can say give me the names of the elements in the list. So names in this case is a function that accesses the list and tell you if the list has names. And in this case, it's returning value, word, and number. Okay. These techniques are also applied to what we call another composite data type, which is the data frame, okay, which is one of the key players in R. Okay. Vectors. So this is another composite type in R. It's very similar to lists, but the main difference between vectors and lists is that vectors are homogeneous in type, meaning that they have all the elements in the vector have to have the same type. Okay, they cannot be nested. It means that a vector cannot contain a vector inside. A list, yes, it can contain a vector inside. And the way to create a vector, remember I told you I was avoiding to use the letter C as a variable name, is by using the C function, which combines different values into a vector or a list. So if I say A, C, 1, 2, 3, I'm going to be creating a vector with the values 1, 2, 3. If I say B, C, hello world from a vector, it will be creating a vector all from strings. Okay, and if I ask for the structure of B in this case, it will say it's a vector of characters and then all the values in there. Okay, we're going to come back to vectors, are really important, and the reason for their existence is that they can optimize a lot of operations because the homogeneity of the types within the vector, so it can make things run way faster than when dealing with lists. Okay, but we're going to come back to that. Okay. Almost at the end. I know I'm running a little bit longer in time, but I will be done in 5 minutes, I promise. There are a lot of data sets. I told you R is the niche, or the niche of R is data, analyzing data, digesting data, processing data, however you want to think about that. And one of the things that R brings along is a lot of data sets already cooked inside R, so you can use the data parenthesis function, and it will show all the data sets that are part of that. You can pick your favorite, you can look at the structure of those data sets, and it will give information about that. If you are doing that, if you're doing the data thing, just press Q to get out of the data menu. Okay? Data frames. This is the most relevant data structure that R holds, and it's super important. You can think of a data frame as a spreadsheet. That's the main idea. We're going to spend almost one whole class talking about data frames, but basically each column is like a list of vectors, or the data frame is a collection of lists of vectors. So each vector contains information, and you can access that information in a very similar manner as we did with the list. So for instance, I'm taking from that data sets that R has the one called trees, and I'm calling referring to them as data, so you can access it. So if I ask for the class of data, it's telling me, okay, this is a data frame. If I ask for the structure of data, it's telling me this is a data frame where there are 31 observations of 3 variables, which means it has 31 rows with 3 columns. And the columns are called girth, height, and volume. So these are measurements of, I believe, are orange trees actually, where there is the girth of the tree, the height of the tree, and the volume of the tree. So you can see how those values correspond to each other. Again, we're going to come back to this. I just want to let you know because this is one of the composite types in R. In the same way that we can access the names of the list, we can also access the names of the columns in the data frame. So I can say names of data, and I will get girth, height, and volume. Now, if I want to access the first 3 rows in the data frame for the column girth, I can take my data frame, use bracket, single bracket notation in this case. 1 to 3 will give me the first 3 rows from the column girth. So this comma means the first position are the rows I want to select from the data frame. The second position after the comma means which column I want. Okay, and what is returning is the 3 values stored in the column girth for the first 3 rows. I can also get different rows. I can get rows 2, 3, and 5 from the data set, and if I don't specify anything, I will return all the columns in the data frame. So data of the vector, what I'm doing here is I'm defining a vector to slice the data frame. Remember that word is super useful in R, super powerful and super efficient. 2, 3, and 5 is my vector. So I'm going to get rows 2, 3, and 5, and all the columns because I'm not specifying which column I want. Okay. Getting data from external sources. So again, we can read data from external places, either CSV files or places in the internet. For instance, I'm reading here a CSV file located at this URL, and the function I'm using is read.csv, parentheses, and then between quotation marks, because it's a string, the URL, all the file name I want to read. So just for the structure of the data, that's the information about it. I can get the column names or the names of the data. It's the same thing in this case, and you will see what the kind of data is stored there. Just wanted to let you know this is possible. Okay. One final thing. Many of you may be working in Excel. I hope that after the course or during the course you migrate all your data analysis techniques from Excel to R, and there are several reasons why you will want to do that. We are going to discuss some of them later on, but one of the things that you can do is use an external package. There are a couple of them actually that will allow you to read those Excel files. I have this slide more like a teaser for you to know it's possible to read also Excel data, and each of these packages has advantages and disadvantages. One of the things that you need to bear in mind is that you can read one sheet, one spreadsheet at a time. But again, it's something, because we get this question many times, can I import my Excel data into R? And the answer is yes. And you will do it with one of these packages. There is the XLX package, Sheet Data package, Excel Connect package. Any of those may work. XLX is one of the best ones, but it requires to have Java running in your computer. So again, if you're interested in that, I will be more than happy to chat with you about that. Okay, and almost at the end. So this is a summary of what we covered today. I know I'm running a little bit out of time, but basically we have seen R as an interpreted language, super power for data analysis and statistics. We recognize the primitive data types and the composite data types, vectors, arrays, and lists. Okay, then I have a question, and let me see if I can address that, and we can finish with that. I don't believe so. So the question is, R does not have a pop-up window for the commands like RStudio. No, it doesn't. It will pop up your graphic output, but not your, so the commands will show up in your terminal. So it won't show up in a different window. Okay. I will be in the chat for a little bit longer. I'm going to stop the audio and the video, but if you guys have questions, feel free to write either in the Zoom chat or in the course website chat. I will be looking there for a few more minutes. Please don't forget to, that's the last thing I want to show you. Don't forget to complete the survey in the course website. So you will see in a second how does it look like. I'm going to refresh this. That's the course website, by the way. And at the bottom you will see test. It's not a test, it's a survey. And if you click in office hours, it will say to start the survey, just click on begin, and you should be able to see something like that, where you basically can pick what is your preferable time for having the office hours. Okay, you have until midnight today to complete that. So for next class, for next lecture, I can advertise when the office hours will be. Okay, please don't forget to do that. And as I say, I'm going to be in the chat for a little bit more if you have any questions. Otherwise, I will see you on Thursday.